Hello, and welcome to the first video in a series on sea level rise, prepared to cover topics in bite-sized chunks to make this complex topic more accessible. I'm David Loya, the City of Arcata Community Development Director, and I'm leading the city's local coastal program update. And a key topic in coastal planning is sea level rise adaptation. I hope this video helps broaden your understanding, prepares you for participating in climate change planning discussions, and informs your decisions about the city's adaptation strategies. This video will cover dikes, berms, and tidelands. Specifically, I hope you learn a bit about what dikes are and the history of the regional dike system and how these affect tidelands. This basic information will lay the groundwork for future videos that get into more complex topics. Feel free to jump ahead to those videos if you wish. I'll be using a series of aerial images to discuss dikes and their relationship to the tidelands. Some will be images like this one taken from an airplane at an oblique angle to the ground. I want to start by orienting you to the landscape. This is the southern portion of Arcata with Wiggy, the name the Wiat used for Humboldt Bay, prominently featured. We are looking west towards the ocean, which you can see in the far background. In the foreground, you see Highway 101. Arcata Marsh and Wildlife Sanctuary is in the midground. You can see State Route 255 the background. And here's South G Street. We'll look at those features on aerial images like this one. This is a satellite imagery looking directly down onto the landscape. And this is the same South Arcata area. Here's Highway 101, the Arcata Marsh, Route 255, and Samoa Boulevard, and South G Street. I also want you to take note of a few landmarks so you can orient yourself in these images that I'll show them in a moment. Some of these images have overlays like elevation and topography. Some of them will have projections for future sea level rise. And so those cover some of the landscape features, but these are all fairly prominent in all of the images. First, I'd like you to focus on the cloverleaf or Highway 101 and Samoa Boulevard interchange. This is a good landmark you can see in each of the map scenarios. Keep an eye on that feature. Bayside corners where Jacoby Creek Road and Old Arcata Road intersect is another great landmark I want you to track. And the mouth of Butcher Slough between the marsh and the wastewater treatment plant. This is a prominent feature that's easy to find in all of these images. I'll point these features out as we go along, but you'll be good at spotting them yourself in no time. Okay, let's start with topography and land elevation. This will help us think about how water will move around on the landscape. Here are the three landmarks we discussed to orient you. In this image, we're looking at a heat map representation of elevation. You'll note the channels in Arcata Bay, which are like rivers in the mudflats, are the lowest elevation features in the image. They are represented by the deep, cool blue color. As you move up in elevation on the landscape to the mudflats, a slightly warmer aquamarine is used. Going higher still onto the baylands, agricultural lands between Old Arcata Road and Highway 101, for example, you can see that green is used to represent slightly higher elevation. And the warmer colors will show increasing elevation until you are in the deep red forest lands. You may be noticing that the colors start over again about mid-slope because we run out of colors in the spectrum, but we're going to focus on the low-lying areas around the bay. Okay, focusing on those 3 points again, I want to now take a look at the shoreline as it was mapped in the late 1800s. Now, I realize there's a lot going on in this map on the left-hand side of the image, but we'll just focus on the 1870s shoreline that was mapped. There are several modern features as well you can see, including the landmarks that I asked you to keep track of. And so that helps to orient you. The Bayside Corners is outside the field of view in this image, hidden behind the current elevations map. The blue area shown on the map in the 1870s shows the land that was then part of Wiggy, but no longer is. So the bay included the modern day Arcata Bay that we see as we drive by it, And it also included this entire blue area shown in the 1870s map. The entire area, nearly up to Old Arcata Road and extending into the South G Street residential neighborhood, was all under daily tidal influence. This area would have had extensive salt marshes and areas of mudflats. And you can see the original shoreline of the bay maps onto the green elevation upper limits in the heat map. So that's kind of making sense. The bay occupied the entire lowlands that you see in this image. And then we jump quickly up into red when we get close to Old Arcata Road, Bayside Corners, and just beyond Sumo. So why does the bay extend this far inland today? In the late 1800s and early 1900s, the tidelands were diked for agriculture and industry. This process was referred to as reclamation. Land reclamation is the process of cultivating land that is considered wasteland. In the day, traditional uses and ecological functions of the land were not valued relative to the industrial capacity of that land. So despite the fact that the tidelands never belonged to anyone in the first place, Euro-American settlers in the area, quote unquote, reclaimed the tideland to put them into production. A series of earth dikes and tide gates were placed in the bay to cut off the inland area behind the dike from the tides. This area was then used primarily for cattle grazing and lumber processing. These earthen dikes are now over 100 years old. If they were breached and no other steps were taken to prevent tidal flooding, Wiggy would extend back to its original extent. So what are dikes and what do they look like? Let's take a look at some dikes around Humboldt Bay. A dike is a constructed linear feature designed to direct and prevent floodwaters from flooding the lands behind them. They can be engineered or not. Most of the dikes around Wiggy are not engineered. They can be made of soil, rock, or both. Most of the dikes around Humboldt Bay are made of soil. These dikes are called earthen dikes. And they generally will have tide gates that open when the tides are low to let waters flow into the bay, and close when the tides are high to prevent the bay from flowing into the lands behind the dikes. If you were on State Route 255 at the bridge over the Mad River Slough, just northeast of the town of Samoa, shown here in the aerial, you would see this dike holding the bay flooding, holding back the waters from flooding the lands behind them. A few years back, this dike, which was made entirely of soil, breached during a high tide event. The top of the dike eroded away and a path for the bay water was left to flood the fields. Since that time, the rock you see on the wave slope of the dike was added to prevent erosion. Adding rock to prevent erosion is called armoring. The rock itself is called riprap. And so this berm or this dike was rebuilt and armored. New tide gates were installed and new culverts were installed. You can see the old culvert that they tore out sitting on top of the dike there in the midground. The dikes along Highway 101 used to support a railroad. Now there are other uses on this dike, including the Bay Trail. We look at this area right here, we would see this dike. Looks more like a trail. Though the uses, designs, age, and structural integrity of the dikes vary around the bay, the system of dikes and tide gates maintain the current shoreline. If the dikes were removed, the bay would reclaim most of the pre-1900s area. Most of what you see in this aerial image used to be part of the bay. The highest elevation, most inland areas were likely high salt marsh and only flooded during seasonal high tides. But the areas nearest the dikes would have flooded on the daily tidal cycles. As we plan and prepare for changing climate with higher sea levels, we need to be thoughtful about managing tidal flooding as the bay waters reach high tides and extend further inland. These tides will eventually overtop existing dikes. In some areas, it will likely make sense to remove dikes and restore tidal influence. These two areas we're showing here are a couple of restoration sites the city has already started restoring tidal influence to. These projects add habitat and make the shoreline more resilient. The dikes were pulled back in these projects and habitat was restored at the two sites, and new dikes were built further inland. So this helps restore tidal influence to these areas and creates more tidal habitat. Some areas where there is more infrastructure, like the South G Street neighborhood, will require more planning to ensure an equitable retreat strategy. We will explore these topics in more detail in upcoming videos. Thank you for watching part 1 in the series. I hope this information helps us understand what dikes are, how we rely on them to manage floodwaters today, and how they have affected the bay. For more information and to learn about events, go to the city's website at www.cityofarcata.org or search Arcata Sea Level Rise. You can also sign up for the city's listserv about local coastal program events on the city's website. Feel free to reach out with questions or comments. Bye for now.